Alright, this video is for section 5.3, which is still about annuities. Same thing that we talked about already in 5.2, but now we're going to be talking about present value. So this would be, say for example, maybe like a retirement account. You want to know how much do you need to have in your retirement account when you retire so that you'll be able to make withdrawals, you know, every month for a certain period of time. Alright. But it can also be used to figure out how much of a loan you can afford to get, you know, if you can afford to pay a certain payment each month. Alright. So, all of the variables still mean all of the same things as they did in the previous section. So let's look at a nice practical example. So it says you would like to be able to retire at age 65 and withdraw $3,000 per month from your retirement account until age 90. If you start saving at age 20, how much must you save each month to achieve your goal, assuming a 7% interest compounded monthly? Okay. So $3,000 is the payment that we want to be able to take out. So that's capital R. Alright. And then we're going to have lowercase r, the interest rate would be 0.07. And it's compounded monthly. So M equals 12. Alright. And you want to be able to take those payments out from 65 to 90. So let's just do 90 minus 65 is going to be equal to 25. Alright, and we'll figure out the present value first of how much you need to have in the account at age 65. So we use that formula. Be 0.07 over 12 to the power of negative 12 times 25 and then divided by 0.07 over 12. Alright, so let's put that into the calculator and see what we can come up with. Oops. As usual, I forget to put my multiplication. Alright, start over. 3,000 times 1 minus 1 plus 2 to the power of okay, that'll work. Yeah. All right. Let's see. It's giving me a negative answer. Is that right? Okay, I see what I did wrong. I need to have this parentheses right here. Yeah, I forgot that one. We need that one here. Okay, and then once we put it in like that, we don't get a negative answer, so that makes more sense. So we got $424,460.71. So that's the amount of money that you would need to have in your account at age 65 when you retire. Now, if you start saving at age 20, how much must you save each month to achieve your goal? So for that, we would need to use the formula from section 5.2 and solve for that payment. So for this one, we're going to be solving for capital R, and they still have the same rate, and it's still compounded monthly. And the time in this one is from 20 to 65, so we could do 65 minus 20, which equals 45. All right, so let's remind ourselves of the formula from 5.2. There it is. All right, we're going to be solving for R. So basically like this formula over here. All right, so we'll take the future. So now that present value is actually that's the present value when you're 65, but when you're 20, that's your future value. So we take that value. So we're trying to find R. R equals $424,460.71. It's the future value over all of that. All right, so over, I think we need like three of those. 1 plus 0.07 over 12 to the power of 12 times 45, and then we got minus 1, close the parentheses, and divided by 0.07 over 12. All right. Let's see if we could type that in the calculator and see what we get. All right. So this says $111.92. That's not bad. So all you have to do is save $100 a month. Not bad. Alright, so I thought that was a nice practical example to start off with, but here's probably a much simpler one. Find the present value of an annuity with payments or deposits of $450 per quarter for 20 years at 6% interest compounded quarterly. Alright, so we've got capital R is 450. We've got T is 20. We have little r would be 0.06. M is 4. Alright, so we want to find the present value. So start with 450 times, let's see, let's look at the formula again real quick. Alright, 1 minus 1 plus 0.06 over 4 to the power of negative 4 times 20. Let's see. And then just about it. Yep. All over. Yeah, make sure I gotta close that one and then put it all over 0.06 over 4. Alright, so we're going to type that in our calculator and see what we can get. Times to the power of over. Alright, so I got $20,883.30. So that's how much you would have to have in an account now in order to make withdrawals of $450 per quarter for 20 years. Alright, now as I mentioned earlier, this formula can also be used to figure out how much of a loan you can afford if you know that you can afford a certain amount of payments. Alright, so just using the same formula, so if you can afford to pay $100 a month for 4 years, how much can you afford to borrow at 6% compounded monthly? And how much interest will you pay? Alright, so we've got R is 100, that's capital R, the payment amount. We've got T is 4. We've got the rate is 0.06 and it's compounded monthly, so M is 12. So present value equals Okay. Times. Alright, so let's plug that in. Okay. All right. $4,258.03. Alright, so that's how much you can borrow. Let's figure out how much interest you would pay. So to do that, we would figure out how much you would actually pay minus the amount you borrowed. So you paid $100 a month times 12 months in a year times 4 years minus the amount you borrowed, which is $4,258.03. So that's $541.97. All right. So if you buy a car for $6,000 at 5.5% compounded monthly and pay back the loan over 3 years, how much will your monthly payment be and how much interest will you pay? Alright, so we got to use the same formula, only we got to solve it for the capital R, the payment. So just like same thing we did with future value. So it's going to be present value, R equals present value divided by all of that stuff. Alright. So we're going to use R equals present value divided by all of this. Let's see. Okay. Alright, so that's basically the formula we're going to be using. So in this case, we've got the present value is 6,000. Little r is 0.055. It's monthly, so M is 12. and 3 years, T is 3. Alright, so we want to calculate for R. So that's going to be 6,000 divided by 1 minus 1 plus 0.055 over 12 to the power of negative 12 times 3 over 0.055 over 12. Okie dokie. Let's type that in. Okie doke. $181.18. Alright, so that's your monthly payment. And then how much interest are you going to pay? So that's going to be the amount that you total paid, which is the monthly payment, $181.18 times 12 months in a year times 3 years, minus the amount you originally borrowed, which was $6,000. $522.48. Alright, so let's do an amortization schedule. So an amortization schedule shows that how much out of each payment goes for interest and how much goes for principal. Alright, so suppose you purchase a car for $7,895, making a 5% down payment and amortizing the rest for 3 years at 1.5% per month. Okay, so first of all, let's take off your down payment. So the fastest way to do that is to just take the price of the car and multiply that by 0.95. So that'll tell you what the principal of your loan was after you took off the down payment. Because we don't really have to know what the down payment exactly was in this case. Alright, so after you take off the down payment, your balance of your loan is $7,500.25. Alright, so you start off with your loan balance, original loan balance is $7,500.25. Then, okay, you're going to pay 1.5% per month for, okay, so we have to figure out the total amount of your payment. Alright, so this is equal to your present value. So we're going to use this formula that we just used on the last problem to find out how much your payment is. So it's 1.5% per month. So we can go, so basically I equals 0.015. So we don't have to divide it because it's already per month. Okay. To the power of negative, so it's per month, so it's 12. It's for 3 years, so times 3. Okay, close it, divide by 0.015. Alright, so let's put that in the calculator. Alright, $271.15 is your monthly payment. Alright, so now we need to figure out how much interest you have to pay with your first payment. So to do that, we're going to take the principal of the loan multiplied by the monthly interest rate. So 7,500.25 times 0.015. So 112.50. So that's the amount of interest that comes from your first payment. So the rest of your first payment, which is a total of $271.15, gives you the amount that you're paying towards your principal on that first payment. So 271.15 minus 112.50. So that's 158.65. Then you're going to take your previous principal, which was 7,525. You're going to subtract the amount you're putting towards the principal out of that payment, which is 158.65. So that gives me 7341.6. So that's first payment. Then let's look at second payment. Alright, so on the second payment, to figure out the amount of interest that we have to pay, we take the balance we're starting with now, which is 7341.60, multiply it times our monthly interest rate, which is 0.015. So 110.12. That's the amount of interest that's coming out of our second payment. Then we take the total amount of the payment, which is still $271.15, subtract the amount of the interest, and that tells us how much we're putting on principal out of that payment. So 161.03. So then to figure out the new balance, we take the old balance, 7341.60, minus the amount we're able to put on principal that month. That's 7180.57. Alright, so it just would continue on like that, and luckily we have things like Excel spreadsheets that can do all that math for us, but now you know what math it's actually doing. So, and as you notice, each month as you reduce the principal, the amount that's going towards interest from each payment is going to go down a little bit each month, and the amount that's going towards principal is going to go up a little bit each month. So, alright, suppose you take out a 30-year mortgage for $140,000 at 5.9% compounded monthly. Find the minimum monthly payment. Okay. So, we're looking for that R. So our present value is 140,000. T is 30. Little r is 0.059. It's monthly, so M is 12. Alright. So the payment would be equal to 140,000 divided by, let's see, how many parentheses did I need? 2. And if you don't already know this, it's going to blow your mind. Well, not yet. Not until I tell you how much interest you're actually going to pay. Okay. Alright, $830.39. Alright, so that's not so bad. Although, by the way, it doesn't include your taxes and insurance and all that stuff. That's just your principal and interest payment. So that's your payment. But now you gotta check this out. Alright, how much interest are you gonna pay? Well, you're gonna pay $830.39 every month for 30 years. Alright, and then let's just go ahead and subtract the amount that the mortgage was actually for. So the answer we're going to get here is just going to only tell us how much interest we actually paid. Alright, well, hey, look, there is how much we total paid for that house. So we paid $300,000. So we actually paid double. So $158,940.40 worth of interest. So this is why you want to try to pay off your house as soon as possible. And hey, at least at the end of all this you have a house to show for it, unlike if you're renting. So anyway, that's all I've got for this video. Hope you find it helpful. Let me know if you have any questions.